transportation is taking place, and the downstream is where crude oil is processing. Okay, so crude oil first come to us. Then what is the very first property which is very necessary before going through the distillation process? So first we will check the water content of the crude oil. Why? Because without knowing the water content into the crude oil, if you started directly the fractional distillation, it will create the problem during the distillation process. Do you know 1 ml of the water, when you heat up, that water vapor occupying the area which is 1700 cc, more than that of 1 ml of oil vapor. So it will clear the hurdle during the distillation process. So we will first check the water content by Dean and Stark method. Dean and Stark is the name of scientists who designed this method. In this method, what we will do, we will take the 100 ml of the sample and 100 ml of the solvent. Which type of the solvent is required for the water content? So we will take a such type of solvent which can make the azeotrope with water. Isn't it or not? Can somebody explain what do you mean by azeotrope? Azeotrope. Azeotrope. Close boiling point mixture. You can say in a layman language, close friend. So you will take a solvent which can make the close friendship with water. So I will take such type of solvent which has got the boiling point near to water. So I am taking toluene because the boiling point of the toluene is 108 and water is 100. So it will carry that water along with that toluene. So there is a distillation column and graduation part is there. So it will reflect, and water, as you know that water is heavier than toluene, it will settle down in the graduated marking parameter. You can check if the water content of the crude oil is 0.3% volume by volume or more than that, then you will have to go through the dehydration process before going through the TBP distillation or going through the fractional distillation. Okay, so once if water is 0.3% or more than that, we will have to do the dehydration process. So for dehydration process, this is the dehydration unit basically. Only in that to put the simply hollow glass column and how much capacity you required of the crude oil for the fractional distillation, that much amount you will have to take. But before taking the crude sample, it has to be kept inside the freezer at 0 degrees centigrade at least 1 hour, so that there should not be any losses of lighter hydrocarbon like C1 to C4 or C5. Okay, so after doing all these things, now I will put, this is my hollow column, and this is my condenser, this is fraction cutter, and this is receiver, and this part is known as a reflex head. Okay, so if I require, see, whenever you are doing the fractional distillation, there is a particular condition. How much minimum sample you will have to distill and how much maximum sample you will have to distill. For that, you will have to mention the height of the column and height of the condenser, fraction cutter and receiver. So my condition had been optimized for minimum 1.5 liter of the crude oil and maximum 20 liter of the sample. For that I have a column for fractional distillation. Now, dehydration process, you will have to keep your condenser at minus 20 degrees centigrade. Why? Because as we know that at minus 20 degrees centigrade, my C1 to C4 will remain in vapor form. That is also known as LPG potential, or you can say the debutanization of the crude oil. Okay, so what I will do, I will maintain my condenser at minus 20 degrees centigrade. There is a crude oil, you will have to heat up it gradually, and as we know that at minus 20 degrees centigrade, your C1 to C4 will be in vapor form. That there will be a stopper, and you will keep the balloon like this over here and then heat up the crude oil. Now at minus 20 degrees centigrade, how will you come to know my C1 to C4 has been removed or completely removed from the crude oil? So as I told you, my condenser will be at minus 20 degrees centigrade. How I come to know? When C5 comes, when that C5 vapor touch this condenser, because condenser is at minus 20 degrees centigrade, that C5 will convert into the liquid. Okay. Otherwise C1 to C4 will remain in paper form. But when C5 comes, that C5 will condense over here and there will be a liquid drop. Once you have seen the liquid drop, now you come to know my C1 to C4 has been removed completely from the crude oil. Okay, so initially we have taken the weight of the crude oil. After removal of the C1 to C4, let it come into the room temperature, then you can wait again. So there will be obviously a loss. That loss has been captured inside this plastic balloon. This balloon directly goes into the GC lab, and that GC lab will directly inject the C1 to C4, and there you will find the whole composition of the LPG potential or debutanization of the crude oil. Okay, now C5 onwards. Now it is going to be condensed completely, C5 onwards. Here you will find the hydrocarbon up to 100 degree centigrade or 105 degree centigrade along with the water. You are going to collect through this fraction cutter into the receiver, because your all three things will be at minus 20 degree centigrade. Okay, so now question is coming that how I come to know my water has been removed. See, if there is a water inside the crude oil, so you will find the haziness come all over the column. Once water has been removed, you will see the column like this. It will seem transparent. So now you come to know, okay, my water has been removed. So once you have collected the water along with hydrocarbon, that you will have to separate out. Then you will have to take the weight. What is the weight of the water? Because that water is not the part of crude oil. So you will have to subtract it where you have initially taken the weight of the crude oil. Okay, and the lighter hydrocarbon which you have collected up to 100 or 105 degrees centigrade, that you will have to keep inside the freezer until your crude oil that dehydrated crude oil will not come at room temperature. Otherwise, what will happen if you are directly pouring back that lighter hydrocarbon inside the hot crude oil? So it will again evaporate. So I will wait for at least 24 hours. Then next day I will pour back my lighter hydrocarbon inside the dry crude oil, then again wait. So there will be material balance. Is there any losses? Obviously there is a loss of removal of C1 to C4. Now here you will come to know, okay, what is the potential of C1 to C4 inside the crude oil, that you come to know, and the composition you are going to get from the GC lab. Now your crude oil is ready for the distillation process. Now your crude oil, you can say your crude oil is ready, or your dry crude oil is ready for the distillation. Because distillation says that when you are doing the fractional distillation, your crude oil should be dry in nature. Okay, and second thing which is very very important, the method by which I am doing the distillation process. As we know that distillation is a process by which we can separate or we can segregate different boiling point compound according to their boiling point. Okay, because crude oil has different boiling point compounds, so it has to be distilled by the fractional distillation. As we know that there are three types of distillation. One, fractional distillation. Second, semi-fractional distillation, and simple distillation, non-fractional distillation. Now, question is arising, what things is required for the fractional distillation? See, two things are very very important for the fractional distillation which is required. One, interaction media, and second is reflux media. One of them is absent, then it is semi-fractionating. Both of them is absent, then it is non-fractional distillation. So crude oil has to be distilled by the fractional distillation. So the distillation which I have, it is as per ASTM 2892. This is a method number, and this method number is also known as TBP, true boiling point distillation. Why it is called true boiling point distillation? Because definition says that the distillation is a process by which we can segregate or we can separate the different boiling point compound.
Speak English slowly because some guys are unable
Okay, no problem. So, okay, sorry. So, yeah, as I told you, for fractional distillation, two things are required: interaction media and reflux media. Okay, so the method which I am using for the distillation of the crude oil, that is ASTM 2892. As we know that ASTM, American Society for Testing and Materials. So according to that, this method is also known as TBP. Because when you will sit in an interview, sometimes it has been asked, what do you mean by TBP? So TBP is nothing but this is fractional distillation. Okay. Now, in this TBP distillation, as I told you, two things are required. And second thing, when you go through the method ASTM 2892, it is mentioned there. Before doing the TBP distillation, that crude oil which you are taking for the fractional distillation, that should be stabilized in condition. What does it mean? Crude oil should be stabilized in nature. What does it mean? This is a very, very important question which has been asked in an interview also. Crude oil which we are taking for fractional distillation, it should be stabilized in nature. What does it mean? Stabilized means we are, again, this you just keep in your mind. Stabilized means the reed vapor pressure of the crude oil should not be more than 82.7 kilopascal. The reed vapor pressure of the crude oil should not be more than 82.7 kilopascal. If it is more than 82.7 kilopascal, then that crude oil is not stabilized in condition. Got my point?
Should not be less than.
Should not be more than 82.7 kilopascal. 82.7 kPa, kilopascal.
Is for stabilized food.
Stabilized. Should not be more than 82.7 kilopascal. I am coming that point. Obviously, this is the second question. So, what is the reason it should not be more than 82.7 kilopascal? See, dear, when you are doing the fractional distillation, after completion of the distillation, you will have to take the material balance. Okay, final distillation. Now you will check. Initially, I have taken 100 ml sample. After distillation, what is remaining and what is the product, plus and what is the loss. During the fractional distillation, your loss should not be more than 1%. Got my point? Is the loss during the fractional distillation, your material balance loss should not be more than 1%. 1%. Now, why it is so? See, where you are standing, I am taking minimum 1.5 liter sample and maximum 20 liter of sample. If you are distilling 20 liter of sample without knowing that my crude oil is stabilized or not, so finally when you do the material balance, you will find your loss is more than 1%. So who is the responsible when in the refinery where trillions of crude oil are distilling and now multiply by 1%, how much loss you will get? Who is responsible for that? So initially you will have to check the reed vapor pressure of the crude oil. So we have a method that is ASTM 323. We will take the 125 ml of the crude oil and we will check the vapor pressure which is present into the crude oil at 37.8 degrees centigrade. If that vapor pressure is more than 82.7 kilopascal, maybe that is there, we cannot do, but yes, we can mention in the report. Because crude oil is not in stabilizing condition, that is why the loss of this crude oil is this much. So then this is the justification. But without knowing the reed vapor pressure and you have distilled the crude oil and you are getting the loss which is more than 1%, then now it is your responsibility. Why this happened?
If you get reed vapor pressure more than 82.7,
It should not be more than 82.7 kilopascal.
if you get more than 82, say
Yes.
you get 92,
Okay.
what does you do at that time?
Only we will mention into the report.
Nothing else.
Yeah, nothing else. Only we will have to mention into the report because the reed vapor pressure is this much and crude oil is not in stabilized condition. That is why my loss is this much. That is there. So that they can take care in the refinery. Okay, this crude oil lighter, so we'll have to take care of that. That is there. So it has to be mentioned into the report.
Sorry, sir.
Okay.
If assume you do your distillation and you see that the crude oil cannot reach the requirement of the refinery, what should you do?
What? I could not understand what you are saying.
I mean, you are doing a distillation here
Okay.
for the purpose of sending the crude oil to the refinery.
Only I am sending the report to the refinery,
Yeah.
not crude oil.
No, I mean report. So if, for example, the report, I mean your distillation
Okay.
does not meet, comply with what they need.
Not comply.
Yeah.
As far as my experience is concerned, I have 18 years experience. So far, I did not find any difference between our report and the refinery result, because here I am taking minimum 1.5 liter of the sample and it is distilling thrice. We are doing the distillation same crude oil 3 times. Which two are matching? That we are sending to the refinery. Again, if I am taking 20 liter of the sample, do you know, if I am taking 20 liter of the sample, it is taking 5 days to complete the distillation up to 370 degrees centigrade. There should not be any, you will have to be very careful. Do you know, when I start the distillation over here, I stand here till there is no any lunch, there is no any breakfast, there is nothing. You will have to stay here only, because the unit which you are seeing, this is totally manual, not automatic. So whatever is happening inside, fully you are responsible for that. If anything is happening, or obviously if you are okay, if you have completed the distillation, so initially you have got the LPG potential, okay, that is there. That report you will get by the GC, whole composition, but the naphtha from C5 onwards, C5 to 140 degrees centigrade. If I am doing anything wrong during the distillation process, the naphtha which you have collected by the fractional distillation, that has to be passed through the whole physico-chemical characteristics. Okay, for example, if I want to skip the distillation, so okay, I will finish this distillation at 5:30 and then go to home and rest. So what I will do? I will make the flooding inside the column. Flooding means so that it should comes out maximum sample at once. That is flooding. So I will clear all these things. What is flooding point and what is dry point, everything I will let you know. But so obviously when you try to make the flooding position, so you will get the product very fast.
Yes.
And you will complete the distillation at 5:30. No problem. Within 1 day. That is there. But where you will cut? First you will cut at density. Because you have a naphtha cut from C5 to 140 degrees centigrade. Before sending the report to the refinery, that naphtha has to be passed through the at least 80 to 90 analysis. So any analysis, if it is failed, it means your TPU distillation is failed. So your first is density. If you have overlapped your product during the flooding, that will disturb your density. Okay, somehow you will manage the density if you are, because you are doing the density yourself, so you can pass it. Okay, let it be. Now second problem is your qualitative analysis. So what is the first example of qualitative analysis? That is ASTM D86. From there you will cut. How? You are going to get IBP, then 5% temperature, then 10% temperature. Somewhere there will be overlapping. If there is be overlapping, now the man who is watching this data, that person will directly call you and ask you why this happened. This is the second thing. Yes.
I have a question about our refinery receive many oil field, different oil field. Sometimes we take oil, crude oil from Middle East.
Yes.
Sometimes we have local oil.
Okay.
So we need, how we can do? We need to send all the sample to here.
No, we are only sending the report, but crude oil first come to us,
Yeah.
and then once if we are not satisfied with the report, we are not going to send to the refinery.
Yeah.
That is why IIP is a government organization. See, IOCL, BPCL, HPCL, all these are limited. So the report which are more reliable on us. So it is our duty. We will have to send the report in such a manner so that there should not be any mistake. We will try to make it, there should not be any mistake. So as I told you that the 18 years has been passed, I did not find any query from the refinery. Is there any problem with it? That is there. If sometimes it happens, I don't find it happening there, but if find, definitely we'll have to sort it out. It is our duty. Okay. And now after dehydration is there, LPG potential has been connected. Now TBP distillation. Now as I told you, initially you will check the IBP. IBP means initial boiling point. So sometimes it has been asked in your head, what do you mean by IBP? And what is the difference between IBP by fractional distillation and IBP by ASTM D86? This is the very, very important question which is asked in the interview. Can somebody explain me what is the difference between the IBP which we are getting from the D86 and the IBP which we are getting from the fractional distillation? The IBP is a temperature where you are getting the first drop inside the receiver. Okay, that is the definition, simply. But my question is, what is the difference, the IBP of D86 and the IBP from the fractional distillation? See, the IBP which we are getting from the fractional distillation, that will be always less than the IBP which we are getting from the D86. What is the reason? Because that is not a fractional distillation and this is a fractional distillation. That is why it is also known as a TBP. Means this unit is giving you true boiling point. But D86 is not giving a true boiling point because this is non-fractionating distillation. So if there is a non-fractionating distillation, obviously IBP will be higher than the IBP of the fractional distillation. This is the first question's answer. Very, very important. Okay. Now second is FBP, final boiling point.
The first question again?
Yeah. What is the difference between the IBP by D86 and the IBP by fractional distillation? So difference is the IBP by fractional distillation is lower than the IBP by D86. It is always lower. If the IBP by fractional distillation is 20, then the IBP of the same sample by this D86 will be either 30 or 35. The difference between these two IBP may be 10 to 15 degrees centigrade. Why? The reason being because this is fractional distillation and that is non-fractionating distillation. Okay?
That's on product.
On product. Now, second is FBP, final boiling point. Here, again question is arise, what is the difference between FBP by fractional distillation and the FBP by D86? Again, it will reverse. Your FBP will be lower in D86, but FBP in this fractional distillation it will be higher. Because here you have a, as I told you, fractional distillation is there and you have a feed which is behind that. For example, if my naphtha boiling point is 20 to 140 degrees centigrade, my IBP is 20 but there is a 30 or 35, but FBP is 140 because you are distilling that crude oil till you are not getting the final drop of the 140 degrees centigrade. But here you are hitting that particular naphtha up where you have a range only C5 to 140 degrees centigrade or 20 to 140 degrees centigrade. So obviously the FBP will be lower because there will be a decomposition inside the flask before 140. Isn't it or not? So the FBP means when you are talking about this D86, for that the definition is, what is the FBP? The maximum temperature at which your temperature drags down, or you can say that there will be a decomposition inside the flask and your temperature suddenly drags down. So maximum retained temperature, after that it is goes down, that is your FBP.
So, teacher,
Yes.
you talked about first drop.
First one.
Yes, initial
Initial boiling.
Initial.
Okay.
Where do you see the first drop? I can see this.
You will see over here. This is for fractional distillation. You can see the first drop. You will find the first drop which is reaching to the reflex side.
Okay.
Here you will check what is the temperature of this.
Thermometer.
That is your IVP. But when you checking the IVP in D86, that I will show you.
This.
D86 is there. That is there. That I will show you practically. No problem. That I will show you. No problem.
So how does it take about for one testing from beginning to the end?
That I will. Let me complete first. Each and everything I will tell you. Let me finish first. At least it will take 1.5 hours. Then you can ask me every question. First, let me finish completely. Then you can ask me. Okay. Yes. Now, because this is manual unit, it didn't seen in refinery. There is an automatic system. And as I told you, what is happening inside the unit by automatic unit, you cannot see. But yes, manually you can see each and everything. What is happening inside the distillation unit. Okay. Now, another point is dry point. What do you mean by dry point? Basically, in a fractional distillation, there will not be any dry point. But when you are doing the D86, there you will have to note down the dry point. What do you mean by dry point? So the dry point, the maximum temperature at which your last drop from the bottom of the flask have been removed, that is your dry point. Okay, so that you can, I will give you some notes also, no problem. Now again, another question. What do you mean by dew point? DUV, dew point. This is again a question which has been asked in an interview.
Appearance upon.
Dew point means when the temperature where your boiling taking place and after that your sample is going to evaporate. That is your dew point. No, sorry. Dew point means the first, when you see the first drop at the top of the condenser, after that it will drop down. That is your dew point. Means dew means your vapor is converting into the liquid and it is due to drop. That is your dew point.
Dew point, yeah.
DEW.
Obviously.
Dew point and clouding point.
Yeah.
Clouding point.
Now, what do you mean by bubble point? These points are very difficult, which has been asked in interview. Bubble point.
The bubble point is like the heat temperature and the heat.
Yeah, first bubble formed, then your sample is going to escape. That is your bubble point. Okay. Now come to the distillation process. Now I will, because this is a manual unit. Now as I told you, for fractional distillation, two things are required: interaction media and reflux media. Interaction means what? There must be an interaction. When you are doing the fractional distillation, there must be an interaction between vapor and liquid. There must be an interaction between vapor and liquid. Otherwise, if your vapor and liquid are not interacting each other, there should not be any segregation. So for interaction, there must be interaction between vapor and liquid. And second, throughout the distillation, you will have to collect the distillate, and side by side you will have to send the liquid back into the column for the interaction. That is your reflex media. Okay. Now first, what the role of the interaction media will take the column. The column which we have, it will take the role of interaction media. Okay. So I am using the column for the fractional distillation. The name of this column is Oldershaw. OLDERSHAW. These are the name of two scientists who designed this column. So this column is also known as perforated plate column. This column is also known as perforated plate column. So the height, the condition which I have optimized for the fractional distillation is, this is 1 meter in height. This column is 1 meter in height, and the internal diameter of this column is 25 mm. Internal diameter of this column is 25 mm, and it has got actual 30 plates. It has got 30 plates, and in one plate there are 80 holes. and the diameter of one hole is 0.3 mm. Got my point? So this column is taking the role of the interaction media.
How many trays?
That I will let you know later. You can ask me each and every question. Let me finish first. I think after finishing my all these things,
No, I thought that you are saying.
actual basic 39,
I do reflux. The same
Zimbabwe.
Now,
Do you understand?
see, basically, this is the internal structure of the column. Got my point? This is the basically internal structure. Inside this type of trays are there. Got my point? So this is just like a thermos flask. At your home, you can see if you have taken the thermos flask. If you want to remain your tea hot for 7 hours, that will cost that much. But if you want to make the tea at least 25 hours should be remain hot, so it will be costly highly. But the importance of this column means you can say for this fractional distillation, this is the heart of the distillation.
How many-
If I remove,
How many layers?
I will tell you each and everything. Let me finish first. Let me finish first.
Yes.
I think after completing my this or wise things, there should not be any question. I'm confident.
Okay.
This is my 18 years experience. So that let me finish first. If any query, definitely I will make you understand. So this column, this is the internal structure and this is the outer cover and then evacuated. Got my point? So this is vacuum evacuated. Okay. Now do you think it is maintaining the pressure inside between this is two wall is there inside that is there and this is the outer wall and then evacuation. There is sealed and it has been evacuated. This column is holding the pressure which is 10 to the power minus 6 mmHg. Now think of 10 to the power minus 6, 10 to the power minus 6 mmHg. Now think of this is 1 upon 1 and 6 times 0. That much pressure it is holding. So when your vapor temperature is 370 degrees centigrade, you can hold the column very easily. There will not be any heat. So that is why it is costly. Otherwise it is totally made of glass. And the silver coating you can see over here. This is silver coating. Okay. What is there everything I will let you know. Okay. So this is the inside and evacuated. It is holding the pressure which is 10 to the power minus 6 mmHg. Why it is there? Because there should not be any heat during the distillation process. Now starting the distillation first. Now because this is a manual unit. Once you have heated up, so crude oil is not that much intelligent, only lighter vapor will come first. Along with that, other hydrocarbon will also comes out. Now my duty is what? Let the vapor reach up to the condensation area. Okay? So the vapor which is reaching to the condensation area, after condensation, whole the liquid is going back into the column for the interaction with the vapor. Now, your question. Actual plates is 30. Now your liquid is going back, condensed liquid is going back into the column and from lower side your hot vapor is coming up. Now between two plates there is a equilibrium. Got my point?
Yes.
Between two plates there is a equilibrium, that is also known as, that you can write please, that is known as,
Right, please.
you can write in capital letters HETP, HETP,
At ATP.
HETP, exactly. Between two plates there is a HETP. What does it mean?
Height equivalent theoretical plate.
Now, height equivalent to one theoretical plate. I am coming your answer. Height equivalent to one theoretical plate.
Oh.
You can write down height equivalent to one theoretical plate. Theoretical plate. Now you can underline theoretical. You can underline theoretical. Okay. Now question is arise. What do you mean by theoretical plate? Isn't it? What do you mean by theoretical plate? Now, just listen carefully. Theoretical plate means the area where vapor and liquid interact each other, and there will be a heat and mass transfer. There will be a heat and mass transfer, and there will be a thermodynamic equilibrium. Got my point? And there will be a thermodynamic equilibrium. Yes. The area between two plates, the area where vapor and liquid interact each other. Dear, this is very important question which has been asked so many times in interviews. What do you mean by HETP? What do you mean by theoretical plates? So the area where vapor and liquid interact each other, and there will be heat and mass transfer. And there will be heat and mass transfer, and there will be a thermodynamic equilibrium. Okay, now got my point? So between two plates there is a one theoretical plate. Between two plates there is a one theoretical plate. So what does theoretical plate means? Purifying stages. Obviously theoretical plate is nothing but it is purifying stage. Obviously. So in such a manner, for example, I have started the distillation. Whole the vapor is reaching to the condensation area. After condensation, liquid is going back into the column for the interaction. Now talking about HETP or one theoretical plate. For example, if my IBP or initial boiling point of the vapor is 20 degree, for example, so along with that 20 degree centigrade, 30 degree, 40 degree, 50 degree centigrade boiling point compound will also comes out. But what will happen? When time and again you are sending the liquid back into the column for the interaction, so there will be an equilibrium of 20 degree between these two plates. Once there is a equilibrium of 20 degree centigrade between two plates, obviously the boiling point which has got boiling point 30 degree, 35 degree, 40 degree, definitely that boiling point compound will settle down. So how that will goes back, now I will show you. Here is a cut which is known as wearing height. Okay, and this is the capillary which is known as downcomer. Okay, once your liquid will filled up to this point, and once equilibrium has been generated, your heavier boiling point compound will goes back into the flask. That you will see practically when I will show you. So definitely that higher compound will goes down. So in the similar fashion, again between two plates there is another theoretical plate. So once now question is arising that how I come to know my equilibrium has been generated throughout the column, because my main aim is what? To make the equilibrium inside the column. So the role of interaction is taking place inside the column. Now come to that point where I come to know my equilibrium has been generated. For that I have kept my thermometer just above the column. Now once it will take 25 to 30 minutes once equilibrium has been generated inside the column. So I come to know, definitely you will find after 30 minutes you will see your thermometer temperature will remain constant. Obviously initially when you are heating, so your temperature will not be a constant, but once equilibrium has been generated, obviously you will find the thermometer temperature remain constant. If thermometer temperature remain constant, then you come to know, okay, my equilibrium has been generated throughout the column. Now the role of reflex media will be started. Reflex media means, which you can say reflex ratio. That is R equal to L upon D. R equal to L upon D. This you can write. R equal to, in capital letters, R equal to L upon D.
R equal to.
R equal to L upon D. Right. Now initially as I told you, from 25 to 30 minutes my D will be 0.
2.
Okay. For 25 to 30 minutes my D will be 0. If my D will be 0,
2.
then what will be the R? Initially for 35 minutes, if it is 0, then what is the value of R? Infinity means this is known as complete reflex. Again dear, this has been a question which is asked in interview. What do you mean by complete reflex? What do you mean by complete reflex? So if initially for 25 to 30 minutes, if D is equal to 0, then my R will be infinity. So infinity nothing but whole the vapor which is reaching to the condensation area, that is completely going back into the column for the interaction. That is called complete reflex. Got? Complete reflex. Now my duty is what? I have to collect the sample also, I have to collect the distillate also. Otherwise, what is the use of that? You are sending the vapor and going back into the column, what is the use of that? So now my role is to collect the sample, and throughout the distillation you will have to send the liquid into back into the column, so that there should not be any disturbance inside the column equilibrium. So for that you will have to send the liquid back into the column. Okay. Now once equilibrium is generated, then I will start my reflex media. So why it is important? You can see there is a Indian jugaad, you can see. Each and everything you can find in market, this thing. Or technically it has been set up in such a manner. This thing you can, this is only rupees 150 only. And the unit, automatic unit of the fractional distillation is 2 crores. The cost of this unit, only my column cost is 5 to 7 lakh only. Otherwise these are the accessories. And the work which I am doing by this column, that work is not done by that automatic unit which is costing 2 crores. The biodiesel, bio-oil cannot be distilled by automatic unit because there is a sensor. If there is a uneven boiling happen inside during the distillation, automatically that unit will close or give this iron, your temperature is uneven, that is why it is shutting down. But here it is a manual unit and giving so much, only costing 7 lakh, but we have earned so many things by this unit. So that is why it is very interesting. So I will show you the role of reflex media, very interesting. So before I will talking about this, tea is there, tea is waiting for you. First we will take the tea, then we will start from reflex media. Okay? So now first we will take the tea. Okay?
Now you know it. What is a TBP?
BBB.
Two boiling point.
Sample collection from the.
So you want to use it the same?
Yeah.
I think it's very important for you.
Yeah.
I sent to you in the morning.
This is the
Lecture. Morning. I sent to you. Check WhatsApp.
the lighter one. Lighter.
Good one, yeah. Good for you.
Sorry, the heavier will be. Because
Okay.
we have one gas chamber issue.
So heat from here. Yeah, heat from.
The water vapor will come back because from here it's minus 20. It can go up. Why do we need to make this much freezes? For the LPG ones, because the freezing point
Go, freeze.
those gases. C1 to C4, it's less than 30 degrees Celsius. See, it is heated up to say like 70 degree or 100 degrees. Yeah. This is also minus say like 10 degree. This is minus 20 degree. Minus 20 degree. So overall will be the difference, the temperature difference will come higher, so that the breaking down process will be more efficient. You feel
Exactly.
right?
Come here.
First of all, when we heat, the vapor will come from here. Yes. Right. So the vapor might contain the water vapor, might contain the light gases. Light gases means C1 to C4, and when it at first they will heat up to 20 or 40 degrees Celsius, right? Or 50 degrees, 100 degrees Celsius. Yes. This ship that he will heat up to 160 degrees Celsius. So during that heating, if there is any water vapor, the water vapor will get cooled in the condenser. Okay. Right? And the water, it will fall from the drop. And the drop will come back here. But from C1 to C4, since their freezing point is below 20 degrees Celsius, that vapor will transfer from here, and then it will be in the machine. So you mean the moisture in overall, moisture will be separated from the crude, and then it is collected. What happens? The vapor is coming from this, starting from here, right? So whatever the water vapor are formed, they will come down.
Yeah, so
Here. And it won't go there. So it will come here, and then you get collected from here and take the weight. So it will not vaporize again.
no,
It will not vaporize again. Because it's
This is kind of locked off here too,
yeah.
right? So you see when you have that evaporation process and then you have the condensation process, is that it tends to flow on the wall.
You will
Because it
see the
condenses on the
droplets
wall.
here. You will see all the
So
droplets
this is
here.
condensed inside but on the wall because that's where it cools.
Yeah, let's go for tea.
Let's go.
You know, minus 5 degrees. So different pressure.
Have you also been working with this kind of device?
Well, we work with simple distillation units, but not specifically for this kind of application. We would have done for purification of samples.
It's oil.
Or even like when,
small one.
yeah.
But the same structure.
But I want to know from here, how is it that they transport this gas to the GC for analysis?
So where's the DC?
I think they collect it here.
I have seen the process.
Oh,
So they collect this kind of bags, and then they give it to the GC with syringe. They will take it. from
manual
syringe.
injection.
Yes.
Yeah.
And then several times, and then they will inject it to the GC.
Oh, you have internet, right?
So this here is a company that I spoke with. They have all equipment for oil and gas
Well,
testing. See-
ZC also.
Yeah. So you see, like for each aspect, refined gas, natural gas, biogas, LPG,
Yeah.
gas and petroleum, and these are the different instruments along with the ASTM methods.
Oh,
so I
ASTM.
requested that. You see, these are the different instruments. So this is a GC. There's an Agilent platform.
Which company?
In a few. So these are all the different. So I guess they even have the automated one to this here. All right. But I mean, to start with, if this works well for them, this is a very good investment because it's quite cheap.
What is the password for the Wi-Fi?
Cannot. I already add, but cannot.
But I have Wi-Fi here. My phone died, so I'm gonna you make sure you take good videos because I'm gonna replicate this. This is a vacuum pump.
This is a pump, I think.
Yeah,
Pump.
this is a vacuum pump.
And go to here, the vacuum here, and then
So I guess they also use it there as well.
yeah.
You know, like even the GC, in the GCMS.